In this video we have another free response AP question referring to related rates. We have the radius r of a sphere increasing at a constant rate of 0.04 centimeters per second. And so here we have our sphere. Now we want to know at the time when the radius of the sphere is 10 centimeters, what is the rate of the increase of its volume? So we're just going to take the volume and differentiate with respect to time. We would get dv dt 4 pi r squared dr dt. Now we're told when the radius would be 10, and we know what the rate of increase of the radius is. We can simply solve this. We have 4 pi times the radius squared, which would be 100, times 0.04, which is 4/100ths, and that would give us 16 pi, and the units would be centimeters cubed per second. And so that would be our answer for part A. B, at the time when the volume of the sphere is 36 cubic centimeters, what is the rate of increase of the area of a cross-section through the center of the sphere? And you can see from my drawing that that cross-section would just be the circular area that passes through the center, and it would have units. It would have an area of pi r squared. So we know that the volume, which is 4/3 pi r cubed, has to equal 36 pi, and the pi's cancel. We multiply by 3/4 both sides, and we'd end up with r cubed is equal to 27, so that r is equal to 3. Now we're looking for dA dt, and so a is pi r squared, and dA dt would be 2 pi r dr dt. We know that r is 3, and we know that dr dt is 0.04, or 4/100ths, giving 24 pi over 100, or 0.24 pi. The unit, since this is area, would be centimeters squared per second. And so that gives us part B. C, at the time when the volume and the radius of the sphere are increasing at the same numerical rate, what is the radius? Well, what we're saying is when is dv dt and dr dt are equal, then what will the radius be? Well, we know from above that dv dt is 4 pi r squared dr dt, and in order for that to equal dr dt, then 4 pi r squared has to equal 1, and r squared is equal to 1 over 4 pi, or r is equal to 1 over square root of 4 pi, or again 1 over 2 times the square root of pi. And that does it for this problem.